Wait for the minute or two for participants to enter. Okay, so I'll start today's session. Um, Welcome to the third week of problem solving for this course, Availability and Management of Groundwater Resources. This week, we'll be discussing problems that are related to the lectures that were taken in the third week. And hopefully this will help you to solve the assignment 3, again, which will be based on the third week's lecture. So in today's session, we'll be covering some problems, sample problems related to the week 3 lecture, plus a few problems from the previous 2 assignments, assignment 1 and assignment 2. Something which I thought might be required to be discussed because they were in some points that we discussed in the problem solving sessions. So we'll be doing that also. So our week 3 lectures are covering majorly on this topic, the Vadose zone and saturated zone. So before we move on to the question discussions, we'll again wait for some time for some participants who might be joining. Okay, so it's about time. We'll move on to the questions discussion. So before we move on to the question discussion, let me just briefly explain a portion based on which majority of the questions will be. So when we look into the soil subsurface and in terms of movement of soil water through the soil, the soil subsurface is majorly divided into 2 zones. One is a zone of aeration and one is a zone of saturation. Now, the zone of aeration, or it can also be called as the unsaturated zone, is the zone where water, as soon as the precipitation occurs on the land surface and falls on the land surface, water starts entering into the soil surface or the soil subsurface, and that portion is called the zone of aeration or unsaturated zone. And it is uh, divided into three layers majorly. First is the soil water zone, second is the intermediate valve zone, and the third is the capillary fringe zone. So the soil water zone is the region which gets the immediate infiltrated water. Water, as soon as it falls down as precipitation, it will start entering into the soil surface, and that portion of the soil subsurface is called the soil water zone. Now, beneath it comes the intermediate Vadose zone. After the soil water zone is saturated with water, the water will start moving downwards into the Vadose zone, and then capillary fringe water zone is the place where water will the presence of water is majorly because of the actions of capillarity of capillarity action and intermolecular attraction of the particles is why the water exists in that region. It is majorly due to capillarity action, and that is how it is obtaining this name capillary fringe. Then beneath the zone of aeration, you can come across the zone of saturation. Zone of saturation is nothing but the part of the subsurface which is fully saturated with water. Geological formations like aquifer and all come under this, and this is the portion at the top surface of which you will find the water table, and it is also called the phreatic zone. Now, the questions will be based on this, so that is why I gave a brief idea about what we'll be dealing with. So I'll move on to the first question. You can type in the chat, type in your answers in the chat box. Daneshan, I'll give you the question and you can type in the answers in the chat box. And once you do that, we can move on to the solution. So the first question we are discussing is this one. The water which is in a state of downward movement under gravity, what is it called? It's called groundwater, Vadose water, connate water, or juvenile water. I'll give a minute or two so that you can read the question and drop in your answer in the chat box. Okay, Danisha said it's B. Since there's no one else, we'll move on to the solution. Yes, so the correct answer is option B. So let's just look into the other terms. So Vadose water is nothing but the water that enters the zone of aeration. Like I showed here, whatever water is coming within these two layers are called Vadose water. Groundwater is the water that is available in this zone of saturation. Now, connate water is nothing but the water that is getting trapped in the sediment pores of the sedimentary rocks when they're being deposited itself. It's not something that is happening as a result of precipitation, but whatever water, if it gets trapped while sedimentary rocks are formed, then such water in the pores of sedimentary rocks are called as connate water. Now, juvenile water is nothing but the water again. It is not as a result of the precipitation or anything. It is water that is forming within the magmatic rocks as a result of magmatic activities that is happening. When this activities happening within the interiors of the Earth's core, if there are water that is resulting as a result of this magmatic activities, then that kind of water is called juvenile water. So the answer here is Vadose water, the water which is in a state of downward movement under gravity. Now we might have a doubt as to why not groundwater. Groundwater is generally the water after the gravitational active, water which is subjected to the effects of gravity. Once it is drained out or once it stops moving, it gets accumulated as groundwater. We'll move on to the second question. What is the process of movement downwards of Vadose water called? Sorry, it's downward movement of water, Vadose water called. Is it called infiltration, filtration, deposition, or downflow? Again, right? The downward movement of Vadose water is called infiltration. This is some portion that we had discussed in the earlier sessions, so week 1 and week 2. So water, as it is a transportation component of the hydrological cycle. Water that is coming in the form of precipitation, as soon as it reaches the Earth's surface, it will start moving downwards into the subsurface of the Earth, and that movement of water into below the surface of the Earth is called infiltration. Moving on. What is the upper surface of the saturation zone called? This was again a question that we discussed in the last week's lecture. Is it called an aquifer, aquifluid, water table, or aquifluge? So we studied about what an unsaturated, I mean, we looked into just what an unsaturated zone is, what a saturated zone is. So the boundary or the interface between the saturated and unsaturated zone uh, is called, like you said, the water table. So we see here, this is the Vadose zone or the zone of aeration or the zone of unsaturated zone of saturation. When the water is saturated, I mean, when the geological formation or the soil here is saturated with water, it is forming this water table, which forms as a boundary between these two zones. So that was the third question. Now the fourth question. Groundwater is not safer than sources of water. Is this statement true or false? Okay. So the statement is false because groundwater is relatively safer than surface water because of the problems such as the pollution and other chemical pollution that is not that to which it is not exposed as much as the surface water is exposed to. Again, we can't say that it is completely pure or very good quality considering the transfer leaching processes and contamination because of landfills and all. But again, when you compare it with surface water bodies, it is relatively safer than surface water bodies because it is also undergoing a lot movement through a lot of layers of soil that is actually kind of making a filtration. So the statement here is wrong. It is not safer. Groundwater is safer relatively when compared to surface water bodies. Moving on to the fifth question. The Vadose water, which is lost to the atmosphere by transpiration and evaporation, is termed as, is it called as soil water? Is it called as intermediate water, phreatic water, or the water table? Right, Danish? It is soil water. So, like it shown earlier, this is the subsurface soil classification or differentiation of the layers of the soil. So water, soil water is the water that is available in this soil water zone. The soil water zone is also called the root water zone. So it is this portion of the soil where roots are highly prevalent and the roots obtain its water, root obtain water from the soil from this portion of the soil. So, and also when evapotranspiration, which is a combined process of evaporation and transpiration occurs, it is basically the water from water that is obtained from the soil water zone that is going off as transpired, the transpired water, and also the water that is available over here that is getting evaporated into the atmosphere. Intermediate water zone is not a zone that is directly accessible, directly in touch with the atmosphere. So it's definitely not the answer. Phreatic water and water table is nothing but the same. Phreatic water is the water that you found in the saturated zone, and water table is the boundary of the saturated and unsaturated zone that is formed as a result of accumulation of water. Okay, moving on to the next question. Which zone is a zone of non-saturation among the Vadose water? So now we are talking about the Vadose zone, and even in the Vadose zone, there is a classification of saturation and non-saturation. So which out of the following is representing the zone of non-saturation in the Vadose zone is what the question is. Okay, that's an interesting answer, but yeah. Hello, Santosh. Welcome to the session. So we'll be discussing questions, and these are multiple choice questions, and you can drop in your answers in the chat box, and then we'll move on to discussing the solutions. So let's move on. So like Danish said, is it A and B, A or B or both? We'll check what's the answer. So the correct answer is intermediate water. So the water movement in the immediate subsurface, that is the zone of aeration, occurs in such a way that when the soil water zone is saturated with water, it is only after that the water will start moving into the intermediate Vadose zone. So initially, as soon as the precipitation occurs, water will start entering the soil water zone, and once this portion of the soil water zone is saturated with water, water will start moving down towards the intermediate Vadose zone. So within the zone of unsaturation or zone of saturation, this soil water zone is the saturated zone, and the zone beneath it is the zone of non-saturation. This is not saturated for a very long time. When I say that it gets saturated and then only water comes down, water is not going to accumulate for a long time over there. Once the capacity is over, it will start moving downwards. So in the zone of aeration, it is the soil water zone, which is the saturated portion, and intermediate zone, which is the unsaturated portion. So that was about this question. Moving on to the next question. Yes, again, just an explanation into this unsaturated zone. This unsaturated zone is also called the aeration zone or Vadose zone. These three classification, soil water zone is a zone that will be saturated first, after which water will move to the intermediate zone, and then eventually water will get into the saturated zone. Now in the saturated zone, this water is going to get accumulated over here, and movement is going to take place in a very small rate. But that's not the case with soil water zone. It's just a temporary saturation, and after which it will start moving down to the intermediate zone. Next question, which zones are collectively known as the zone of aeration? Okay, so I believe the options here are a little confusing. I didn't notice it while putting the questions. So collectively, although the answer is A, I think it is both. It will be both the options because soil water zone, intermediate zone, and the zone of capillary water is collectively called as the zone of aeration. So you can see here, soil water zone, intermediate zone, and capillary fringe are altogether called as zone of aeration. So there, this question, these two options comes together. It was an error while putting the question. So although the answer that I've written here is A, the correct answer will be both of these together. It's soil water, intermediate, and zone of capillary water that is collectively known as the zone of aeration. So sorry about the error from my side. But the correct answer will be A and B. Moving on to the next question. The zone of water which occurs only in fine particle size is called as. Very good, Danish. The correct answer. So let's check what the answer is. So it is the zone of capillary water. Now, like I had earlier mentioned, the capillary fringe or the zone of capillary water is named so is or it comes because there's water present in the zone is as a result of the capillary action of water. So when why do we say it is prevalent more for fine size particles and why not for coarse grain particles? The one reason is capillarity action is taking place as a result of the intermolecular attraction between the water and the particles. Into the pore spaces, water will start moving into the narrow pore spaces against the force of gravity as a result of the attraction between the particles of water and the particles of the soil. So fine size particles always have a larger total surface area when compared to a coarse-grained particles. In coarse-grained particles, the pore sizes are also large. Not only that, the surface area, total surface area of coarse-grained particles are lesser than that of fine-grained particles, and capillarity is one something that is closely associated with the surface area of the particles. So smaller the surface area, um, smaller will be the capillary action. Larger surface area, capillary action or the amount of water entering will be more. So zone of water is more prevalent in fine size particles. One of the reasons why this happens is because of the total surface area of the particles. So that was about it. Ninth question. Which Vadose water zone is also called the zone of saturation? Right? Okay, sorry. Okay, this question is a little confusing. I have mentioned here which Vadose water zone. It's supposed to be which water zone. But for this question, what the answer that you have given is correct. I'll correct the confusion in this question. So the water zone, which is also called the zone of saturation, will be phreatic water or the groundwater zone of saturation. In Vadose water zone, you can call the saturated portion as the soil water. So I'll correct this question again. This is also an error from my side, but the answer that you have provided is correct in terms of this question. So that's about this question. A local water table that is positioned above the regional water table is said to be, what is it called? Right? So this was one portion that we had in detail discussed in the last class. about the various geological formations called aquifer, aquitard, aquiflude, aquefuge. And in that, we also discussed that when an impermeable formation forms like this in between, the water that is getting accumulated for here temporarily is called a perched. This whole formation is called a perched aquifer, and the water is called perched water, or it is referred to as perched. Okay, next question. What is the other name for Vadose zone? Pretty simple question, right? So the other name for Vadose zone is nothing but unsaturated zone. There is also another name called zone of aeration. So these are the three main terms that are used to represent that part of the subsurface soil: unsaturated zone, Vadose zone, or zone of aeration. Now, what is the area where groundwater is drawn up into the pores and spaces in the sediment called as? Right? So we had earlier discussed about the capillarity action. So water that is entering this zone of water is as a result of capillary action, and the water from the water table will start moving through the pore spaces that is available in this part of the soil, and the water there is called the capillary water, and the zone is called the capillary fringe. Okay, so let's move on to the next question. What zone in the unsaturated zone is the most important for agriculture? Correct, Ganesh. So we again discussed about these three zones. Soil water zone is also called the root zone. It is here that almost all the water can be obtained by plants, and hence it is very important to agriculture. Now this is a question you can put in your answers in the chat box. What are the three subzone classification in the soil water zone? So we talked about the subsurface classification, zone of aeration, and zone of saturation. Now, within the soil water zone, which is one of the layers in the zone of aeration, there is three classification in the zone of aeration itself: soil water zone, Vadose zone, and capillary fringe. The question here is, what is the subzone classification of the soil water zone? Topsoil zone, root water zone. Okay, let's see what the answer is. So, a person named Briggs, he classified the soil water zone into three subzones, uh, depending on the concentration of moisture content in these soil water zone. And that is hygroscopic water, capillary water, and gravitational water. So, in soil water zone, there are three types of classification: hygroscopic, capillary water, and gravitational water within the soil water zone. So don't get confused with the capillary fringe over here. So in this zone, hygroscopic water is nothing but the layer of water or water layer that is closely attached to the particles and which cannot be removed as a result of gravity. At times it is lost as vapor, but it is unavailable for any use. Roots and all cannot absorb this water from the soil because it is very closely attached by the particles. Now, capillary water we know, again within this soil zone, soil water zone, there are portions that is there is water that is existing as a result of capillary action. Gravitational water is nothing but in larger force, the water that is getting drained out as a result of gravity is called gravitational water. So this classification is based on the moisture content in the soil water zone. There are three types of classification. One, the soil portions which has got hygroscopic water, the portions of capillary water, and the portions of gravitational water. Again, repeating myself, hygroscopic water is a very closely attached water to these particles of the soil. They are not available to plants. Plants cannot absorb that kind of water because it is closely attracted by the particles of the soil, and it is forming a thin film on the particle of the soil. Capillary water, again within the soil water zone, when pore spaces are closely linked, as a result of capillary action, there's chances of water movement, and that part is called capillary water. Gravitational water is nothing but the water which has a tendency to move out of these large pores as a result of gravity. Okay, moving on. Like I'd earlier said, we will be discussing a few questions of assignment one that required discussion because they were not major topics that were covered during the problem solving session for the first week. So we will just discuss about these problems. Um, so the first question in the assignment one was what is the average annual per capita water availability in India in the year 2031? So definitely this is a projected value. This value has been found out as a result of some computation based on existing results for the future. So these are the four options given, and the option C is the right option that is provided in the answer code. So we'll see some details regarding that. So average annual per capita water availability, according to a reassessment that happened in 2019 by the Ministry of Jal Shakti, the groundwater resources available in 2001 was 1816 billion meter cube. In 2011, it reduced to 1545 billion cubic meter. And in 2021, it was projected as 1486 billion cubic meter. And it is said that in 2031, the water availability, groundwater availability will be 1367 billion cubic meters. And that is the answer that is provided here. So this was based on the reassessment report of groundwater resources, and this can be accessed over here in this link. I have shared this link in this PPT. So when you get the material shared with you, you will be able to access it through this link. And also the details are also available in the lecture transcript. So if you want to go through it again, both these resources are there. So it was based on this that this question was. And some more data regarding this, the dynamic groundwater resources, that is the changing water resources, groundwater resources according to the every year, what is the groundwater resources, that is why we are calling it dynamic groundwater resources, is monitored by the Central Groundwater Board and the various irrigation boards or ministries in the state government. So it is as a result of the joint effect of the Central Groundwater Board and the state governments that such assessments and all are occurring. So according to the 2017 groundwater assessments, total annual groundwater recharge was 432 billion meter cube. In that, out of this 432 billion BCM, whatever annual extractable groundwater resources, what we could extract was 393 billion cubic meter. And in this extractable groundwater resources, what is available for use, although we can extract it, the amount of water that is available for use has been 249 billion cubic meter. And out of this, 221 has been used for irrigation purposes and 25 billion cubic meter has been used for domestic uses. So if a question comes asking which is the major sector that utilizes the groundwater, it is definitely, as you can see the statistics over here, if the irrigation sector is using majority of the groundwater resources more than the domestic uses. So around 89% is consumed by irrigate for the purposes of irrigation, and only 20% is being 10% is being covered for domestic uses. So these are the, as per the latest reports available, which has happened in 2017 or 2019, I'm not sure, but yes, this is the groundwater assessment statistics of the available annual groundwater. The next question is, what is the suggested benchmark for urban water supply in India according to the Ministry of Housing and Urban Affairs? The option provided is D. So if you see again, the Ministry of Housing and Urban Affairs has will design pipelines and networks and the infrastructure available for groundwater, considering 135 liter per capita. That is for one person, 135 liter per capita per day for urban areas, and in rural areas, they are only considering 55 liters per capita per day. So this is the standard for according to the Ministry of Housing and Urban Affairs. The third question was, what percentage of water was used for irrigation out of the total water use in the year 2025 under a high demand scenario according to the NCIWRD report? So this is also not something that comes under the lecture. So I thought I'll give some information regarding this. So NCIWRD is nothing but it is the National Commission for Integrated Water Resources Development Plan. And according to this report, which you can find over here, you can, again, I have attached a link where you can access some more information regarding the NCIWRD. They have analyzed what is the water scenario for 2010 and projected the water use to 2025 and 2050. And here again, irrigation is the major source, consumer of the groundwater resources, saying that around 78% was used in 2010 and around 72% will be used in 2025, and 2050 around 68% will be used for irrigation. So they will be having various models to compute this requirement, and I mean the amount and the how much percentage will be used on various variables. So these are the statistics that they have provided in this report published by the NCIWRD. Question here was, what percentage of water was used for irrigation out of the total water use in the year 2025? And as we see here, it is 72%. So it is option B definitely. So it is based on this data that this question was put. So it would be good for you to go through these. What are the ministries that are taking care of groundwater resources? What are the different plans under the groundwater resources? What kind of schemes are available? These assessment reports for now, whatever is used in this material in NPTEL, I've provided you links where you can do some extra reading about it. Now, which ministry launched the Jal Shakti Abhiyan campaign for water conservation and water security? The option A is the correct answer. Excuse me for a minute. So the Ministry of Jal Shakti, which was earlier called as the Ministry of Irrigation, is responsible for launching this Jal Shakti Abhiyan campaign. We as of now, looked into two ministries. One is Ministry of Housing and Urban Affairs, that is deciding the water limit for urban areas and rural areas. We checked that one question, which is related to the Ministry of Housing and Urban Affairs. Now here, this scheme, the Jal Shakti Abhiyan campaign, was launched by the Ministry of Jal Shakti, and this campaign is focusing on water conservation and water security. Okay. So this here says that it was also a joint effort between the Ministry of Jal Shakti, state governments, and the Department of Drinking Water and Sanitation. Now, the fifth question was, which government initiative is aiming to provide functional household tap connection to every rural household in India by 2024? The correct answer provided is Jal Jeevan Mission. Let's see what are the other schemes that have been provided over here. There's one Atal Mission for Rejuvenation and Urban Transformation called the Amrut Scheme, National Perspective Plan, and Jal Jeevan Mission Har Ghar Jal. Yes, that is what. The answer D is also correct because Jal Jeevan Har Ghar Jal is just a motto to it. So option D is also right. I'm not sure which answer was given the correct. I mean, I hope they have considered people who have given the option D also. This is also a small error in terms of the question. You can raise this as a question in the forum. Explanation which is given further. Okay. Fair. I mean, both the answers are correct. B and D are correct. But while correcting, I don't know if they have considered this. So if there's any issue with the if you're not getting the correct answer, you can raise this issue in the forum, and they'll definitely provide you with the response. So B and D are both correct options. So let's just see in briefly what these schemes are. So Atal Mission for Rejuvenation and Urban Transformation, also shortly called the Amrut scheme, was launched in 2015, and it is focusing on giving basic infrastructures for certain around 500 towns and cities in terms of the water supply, sanitation, and providing water in public areas and recreational areas, non-motorized urban transport. And this scheme was brought under the Ministry of Housing and Urban Affairs. So, like the 135 LPCD for urban and 55 LPCD for rural areas, it is also the Ministry of Housing and Urban Affairs that is having the scheme under it, the Amrut scheme, Atal Mission for Rejuvenation and Urban Transformation. Jal Jeevan Mission that we are talking about here, brought to you by the Ministry of Jal Shakti, is the main focus is to provide safe and adequate drinking water through individual household taps in by 2024 in all households in rural area. And then there's the National Perspective Plan also. This was a plan that was created around August 1980 by the Irrigation Department or the Ministry of Jal Shakti for inter-basin transfer of water. So those water basins which has got surplus of water, how to interlink these basins with areas or rivers that is consisting of less amount of water is the main aim under this National Perspective Plan. So these three are the schemes that have been discussed in this question. The seventh question was, which component of the hydrological cycle that involves water movement as gas and liquid solid in the atmosphere? Correct option is C. There might be a little bit of a confusion that can arise because majorly hydrological cycle is categorized into two components, transportation component and the storage component. Transportation component is a component that consists of all the components of the hydrological cycle that involves flow, like precipitation, infiltration, evaporation, transpiration, runoff. All of these are coming under the transportation component. Now, since here they have mentioned that a component which is involving water movement as gas and liquid or solid in the atmosphere, I don't see how the option is precipitation again. Involves water movement as gas and liquid or solid in the atmosphere. Precipitation is the okay, the water vapor is getting condensed and it is coming down as rain. Might be that. What is the option that you think was appropriate, Dhanesh and whoever is here? Bhaskar. What felt more right to you? Is it option A or option C? Yeah, this seems more right to me. Option A seems more right to me. Precipitation is the movement of water uh, in the form of solid or liquid onto the surface, and movement of water in gas can be evaporation. So I just feel the option A is more appropriate here. Again, this is something that requires explanation. I'll try raising it in the forum. Meanwhile, you can also do the same and try to get a clarification on this. So, so that is there. Then, which of the following is an industrial water conservation measure? So, out of here, reusing cooling water for irrigation. If you see, sweeping sidewalks instead of forcing them is not an industrial water conservation measure. It is a water conservation measure, but it is not very much associated with industries. Low volume shower heads is again a domestic water usage. Growing drought resistant crops is again something related to agriculture. So the only option that seems more appropriate here is reusing cooling water for irrigation. So cooling water is the water that is used in factories and industries to remove the heat, absorb the heat. So using this water for irrigation can be an measure that can be used as an industrial water conservation measure. So yes, the option D seems right. So that was about assignment 1 questions. Then we'll just discuss again two few questions in assignment 2 that might require discussion. In that, again, what type of aquifer is confined between impermeable beds and has higher pressure than atmospheric pressure? Question number 6 in assignment 1. Have you talked about here? Just a second, let me see. Just a second, let me see what the question number 6 is in assignment 1. What is the main source of fresh water on Earth? Okay, I'll share you the PPT that was. Just a second, I'll show you. You can see here the global distribution of Earth's water is in such a way. Out of the total global water, oceans consist of 96.5% of the water. Other saline water, that involves water in marshes, marshy areas, and saltwater lakes and all, are other saline sources. And fresh water comprises of only 2.5% of the total global water. Fresh water is only 2.5% of the entire water is fresh water. Now let's see what are the sources of fresh water. Fresh water includes surface water, that is the waters that is available in lakes and rivers, ponds, streams, and all are coming under surface water, fresh water. Groundwater is the other form of fresh water. Glaciers and ice caps are the third form of fresh water. So if you see within the fresh water, the majority of the water that is contributed to fresh water is from glaciers and ice cap. Around 68.7% of the water, freshwater availability is from the glaciers and ice caps. Groundwater forms the remaining major portion. The second running portion is 30% groundwater, and rivers and lakes are only contributing 1.2% of the 2.5% of the fresh water. So it is based on this question that this assignment problem has come. What is the main source of fresh water on Earth? So total global water, if you see, glaciers and polar ice caps are forming around 68.7%, 1%. Rivers and streams are only, rivers, streams, lakes, and ponds are only forming 1.2% of the fresh water. Groundwater is forming 30% of the fresh water. So it is based on this statistic or this distribution that this question was put. I hope I'm clear, Danish. You can see this this PPT is available in the week 1's problem solving lecture, and that has been shared with you. So you can you have access to them. So you can go through those slides. It has a lot of questions that is discussed about this distribution of water. So you can see those. So freshwater. They're not asking about did they ask the source of fresh water? See, they when we talk about source, it's not exactly the source for which we are the sources of water that is accessible to us. The question was more based on what is the distribution, or in terms of fresh water, which is the major contributing source of fresh water. Maybe it is not accessible to us, or maybe it is of not use in terms of domestic or irrigation or agriculture purpose. But whatever fresh water is available, 68 to 70% is contributed by the glaciers and polar ice caps. What is aware, I mean, for in terms of use, in terms of consumption, the major source of fresh water is river water. We are getting all our water, I mean, whatever distribution networks and domestic usage is based on is on river water. But over the earth, the total global water, fresh, if you take the amount of fresh water, major contributing source is the polar ice caps and glacier ice caps. So there are certain terms that you might want to focus on when such questions are asked. Here they have mentioned question is main source of fresh water on the earth. They have not said main source of fresh water that is for domestic use or for irrigation use or for agriculture. Yes, the question might be a little ambiguous, but when you see such terms like the earth or global water, you can for sure say that it is it is polar ice caps and glaciers. I understand the confusion, yes, but what you can do about it is look out for keywords like I said, is it for domestic use, it is for agricultural use, or is it in the earth, or how much of global water is fresh water? Such questions you can keep a note, or you can take care of such keywords and questions to answer it more correct. So we were in the assignment 2 question discussion. Yeah. So which type of aquifer is confined between impermeable beds and has higher pressure than atmospheric pressure? The answer is D. So you can see here, we had discussed in the last class about the geological formations. So there in aquifers, which are the geological formations that are capable of holding as well as transmitting and providing water abundantly, significantly, is called aquifer. Now, aquifer, there are two types: unconfined aquifer and confined aquifer. Unconfined aquifers are those aquifers where the below of that aquifer is some kind of impermeable formation. As a result of it, water that comes down and accumulates, or it's accumulating over an impermeable formation. So water will keep on accumulate and the water table is there at the top. Now this water table, the pressure on the water table is pre-atmospheric pressure. Now when you go below, the aquifers that are sandwiched between two impermeable layers, like you can see here, the confined aquifers, as more and more water keeps getting accumulated over there, the pressure of the water, that is the pressure of the water, will keep on increasing. It will not be atmospheric pressure. So confined aquifers always have pressure greater than that of the atmospheric pressure, and unconfined aquifer, the pressure of water in there is atmospheric pressure. So it is based on this that the question has been formulated. So it is unconfined aquifer that has higher pressure than the atmospheric pressure. Now, which type of rock is characterized by incomplete inundation, induration, and preserved primary porosity? The correct option is B, semi-consolidated rock. Yes, the answer is confined aquifer. Just a second. Yeah, okay. Okay, so which type of rock is characterized by incomplete induration and preserved primary porosity? There are three types. There was a network issue because of which my internet got disconnected. So I'll share the screen again. Yeah, so we were discussing about consolidated, semi-consolidated, and unconsolidated rocks. So consolidated rocks are majorly igneous rocks and metamorphic rocks. These, while forming, they are being cemented together by the hardening. Induration is nothing but the hardening process, and they are very firmly cemented together during its formation. Now, semi-consolidated rocks are those rocks like sedimentary rocks which is not undergoing a complete process of hardening. They are hardened, but then there are also incomplete hardening process because of which pores are more in such semi-consolidated rocks. And unconsolidated rocks are rocks that is not at all cemented together properly. They can be disintegrated very fast, like the alluvial and everything. So here the question was incomplete induration and preserved primary porosity. It is semi-consolidated rock. The answer B. So that's about the question discussions for today. If anybody of you have any doubts regarding the questions that we have discussed today, feel free to ask. I'll be around here for some more time. So if you have any doubts regarding today's session or you want me to repeat any questions, you can ask, or feel free to leave the class. The video recording and the copy of this question 5 assignment. Yes, Ganesh. So Ganesh, we had learned about aquifers. So aquifers are of two types, confined and unconfined aquifer. Confined aquifer is when the aquifer is found between two impermeable layers, like you see over here. This one, where my mouse pointer is placed. So here, water is accumulating into this aquifer, but it will not be able to go up or go down because it is sandwiched between two impermeable formations. So what happens is, as more and more water keeps coming into this aquifer, the pressure of water will keep increasing because there is a pressure that is applied by this top and bottom layer. Because there's a top layer, now it is going to keep applying a pressure. So the pressure of the water in here is going to increase. Whereas in case of an unconfined aquifer, there is no top impermeable layer. So as more and more water keeps getting accumulated, the level of water will go on increasing upward and upward. There is no layer to obstruct the upward movement of water, the accumulation of water. So the top of the water will always, or the water will always be at an atmospheric pressure. Whatever atmospheric pressure is applied on it, this water will also have that atmospheric pressure only, because there is no layer on the top to constrict the motion of water. So that is why we say that unconfined aquifer water is having atmospheric pressure. So if you measure the pressure of water in this unconfined aquifer, it will be atmospheric pressure. If you measure the pressure of water in unconfined aquifer, it will be more than the atmospheric pressure. So what happens is, when you drill a tube well or dig a well into this unconfined aquifer, water will start gushing into it, and sometimes it will flow out of such wells. Such wells are called artesian wells. That is because there's a high pressure in this water. When you dig wells into it, the water will start flowing out. So it is based on this that the question is put, which one has got more pressure than atmospheric pressure? It is confined aquifer that has got. Oh, sorry, the answer is wrong here. Oh my God. Confined aquifer has higher pressure than atmospheric pressure, not unconfined aquifer. The option is B over here. I'm sorry. Okay. Is that all? Again, this is a question that is very similar to this, has been discussed in the week 2 lecture. If you go through the videos as well as the PPTs, there is one or two more questions regarding this pressure point. Okay. Thank you, Danish, for attending the session. Hi, Bhaskar. Do you have any doubts regarding today's session? Yes, question number two, process of movement, downward movements of Vadose water is called infiltration. That's the correct answer. Okay. Um, I don't know if you will be able to attend the assignment one. I'm not the one who's taking care of the marking, and also maybe good if you could ask, I mean, if there's any contact you have to get in touch with the NPTEL people who are handling this as the assignment submission and correction, it would be better. I don't have, I cannot, I'm not, uh,
Yes, ma'am. Yes, ma'am. Yes, ma'am. Thank you so much. Actually, ma'am, I did late registration only
Okay.
regarding my this subject, NPTEL subject.
Okay.
So that only I asked any possible is there. Again, I attend the assignment
Yeah,
one, ma'am.
I think that will be considered. Maybe you just need to ask them.
Yes, yes. And also we receive sometimes I am not receive the reminder mail also, madam. Sometimes because we are an academician actually, I am working as a faculty. Sometimes I am not receive the assignment message. So in this regard, if suppose I receive the mail from the NPTEL means, so I will follow to attend all the assignments, ma'am,
Right,
regularly.
right,
So this is
right.
my humble request. Don't take negative, ma'am, please.
No, sure. I mean, I understand. Like I said, I'm only handling the problem solving session. I'm not associated directly with the NPTEL.
Yes,
So,
ma'am.
if there's anything you can, if there is any way to get in touch, please do. Otherwise, if nothing is possible, just maybe in the next session, let me know. I will try to get in touch with
In this subject, all the assignment, any both theory and problem, ma'am, otherwise only theory session, like
you.
internal assignment
It's
and
most of them are going to be theoretical problems. There might be a few simple numericals, but most will be theoretical.
that's fine, ma'am. That's fine, ma'am. Actually, can I downloaded previous classes in PDF format notes, ma'am? And I need some tips for how to solve the assignment. Some tips. So before
Okay.
that, suppose I attended all the theory session for this particular subject. So after that, suppose day after tomorrow, I will ready to attend the assignment means. So before that, I need some important tips.
So
So like that wise,
these
I prepared.
problem solving sessions are focused on helping you solve the assignment problems. So every Saturday we will be doing problems that is associated with that week's assignment. So on the first week and second week, I had discussed about the some sample problems that are related to first assignment and second assignment.
Yes,
This
ma'am. Yes,
week's
ma'am. Yes.
problem
That's
is related to the third week. So if you attend these sessions, it will be helpful for you to understand a brief idea of what is happening in that, 4 5 lectures in that.
yes, ma'am. Actually, already assignment one is over, ma'am. Is it correct, ma'am?
Yes, 1
Yes.
and 2 both are over. The solution
Oh,
has also been posted.
okay,
You
okay.
will have a
But
chance
any
to attend
possible
on.
is there? Shall I attend the assignment one and two? Because I did my registration in 4 days before only.
Yeah,
Just
yeah, I
4 days
understand.
before only, I did
I,
I did my I done my registration.
Mhm.
Even though not only for assignment, I have to learn technical terms. After that only, I am willing to attend the assignment.
Yeah, there are transcripts available for download. If you see the Swayam, if you go into the Swayam, there are transcripts for each lecture. What was taught in there is PDF. Plus the problem solving that we are doing now. It has also
Yes,
been uploaded in the Swayam portal under problem solving. You can access the PPT as well as the YouTube video lectures for this
yes,
problem
yes.
solving session.
Yes, ma'am. Yes, ma'am. Actually, which date I am expecting to attend assignment one and two, madam?
Generally, when they post the assignment, a mail usually comes. There's no specific date. In that,
Okay.
they'll mention the last date for submission. So, if you maybe it's just because you registered late, probably there's a discrepancy in the communication. You can get in touch with the NPTEL folks. They'll add your
Okay.
name or something.
So I request to concern NPTEL. After that, I receive the link to attend the assignment one and two. Like that,
Oh,
ways you are explained, ma'am.
right, right.
Yes, yes, ma'am. Thank you so much, ma'am. Thank you so much. Regularly, I will follow the Saturday session, how to solve the assignment. This session really very useful, madam. I listen properly because slowly you are explained in well and good. So
Okay.
because past 5 to 6 years, I am handling the subject also for
Mhm.
both the groundwater hydrology and
Mhm.
water resource and irrigation water management. So like that wise, what we insist to the students, explain to the students, definitely in this lecture, very useful to me. Once again, my special thanks to you, madam. Thank you so
Oh,
much, ma'am.
okay. Thank you, ma'am.
Thank you, ma'am. Thank you.
Okay, so I think that is the end of today's session. We'll meet in the next week with some problems that will help you solve assignment 4. Uh, sample problems related to assignment 4. So thank you everyone for attending today's session. See you next week. Have a good week. Bye-bye.